Hello everyone, welcome to our next video on quadratic formula. This is Unit 1.5, Lesson 14. So let's start with a little bit of a warm-up, shall we? Let's evaluate some expressions. All right, so here what we're trying to do is look at different pieces of the quadratic formula and just get a little bit more proficiency at evaluating different pieces of the formula because it's a fairly large formula, right? Okay, let's take a look. So first part, negative b, given the expression a equals 9, b equals -5, and c equals -2. Okay, so opposite of b. Well, opposite of -5 is +5, so that will just be 5. B squared, well, -5 squared is +25. Anytime you square a number, it will always turn out positive if it is a real number. So now let's do the part under the square root. B squared minus 4ac. So we know that's going to be 25 minus 4 times 9 times c is -2. Okay. So what happens when I have a subtraction with a product that's negative? Well, the negative and the negative will turn positive. If you think about it as a -4 times a -2, that becomes a +8. So 4 times 2 is 8. 8 times 9 is 72. So what you end up with is 25 plus 72, which is 99. No, sorry, 97. So this is 97. So that means that the number under the square root in this case will be a 97. So going from here, let's put it all together. So 5 plus or minus the square root of 97. And then finally, we're going to divide by 2a. So 5 plus or minus the square root of 97 all over 2 times 9, which is 18. Okay, so once we have that piece, now we can look at asking, well, what quadratic equation did we actually just solve for, right? Okay, so remember that a is 9, b is -5, c is -2. So a belongs to the quadratic term, so it's going to be 9x squared minus 5x minus 2 equals 0. And that's written in the most standard form possible. Okay, so that is how we can build a quadratic expression. And yes, one thing to note is that that expression is not factorable. And we know that because in the solution, we had a -97 here. Sorry, square root of 97. Because that does not work out to a whole number, we know that the original expression was not factorable in using the methods that we know. Okay, let's keep going, shall we? What do you feed a baby parabola? Well, let's see. Oh, the quadratic formula. Oh my goodness. Okay. Well, silly jokes aside. Certainly this is a very important formula and very good one to know. So the more that you know this, even without having to necessarily memorize it, like the more that you know how it works and how it's put together, the part under the square root, how all the numbers work together, the better off that you're going to be in using it. Okay. All right. All right, let's take a look at solving some solving some equations using the quadratic formula. So, oh, just lost my pen. There we go. Okay, so remember that in order to use the quadratic formula from our work with the last lesson is that the equation should equal 0. So the first thing I would want to do is bring the 8x over to the other side. So you have the equation now 2x squared minus 8x plus 3 equals 0. That way, we are looking for the x-intercepts now because one side of the equation equals 0. So that also gives us the correct sign for b. So putting it together with the quadratic formula, we would have, so opposite of b, so that's positive 8, plus or minus the square root of b squared. So really negative 8 squared, it's going to come out to a positive anyway, minus 4 times 2 times 3, 4 times a times c, all over 2 times a. We'll just put a 4 there. Okay, so now let's just simplify that down. So 64, 8 squared is 64. And then 4 times 2 is 8, and 8 times 3 is 24. So 64 minus 24 is 40. So now we're going to have 8 plus or minus the square root of 40 over 4. Okay. So now what I do in a calculator, if I want to figure out what the actual x-intercepts are, you definitely would want to put the numerator in parentheses. If you do this in the calculator. If you are just simply finding the solutions, writing it like this generally is a fairly acceptable answer. Notice that all the numbers are divisible by 4, but because the 40 is underneath the square root, we can't divide that by 4. There are other ways that we can simplify this as well, but more on that later. But right now we can put this in the calculator. And we could do parentheses 8 plus root 40. And we will divide that by 4. And you get 3.58 is one of the answers. I'll round it to the nearest hundredth. And then the other one, just change 8 plus to 8 minus. And you have 0.42. Again, rounded to the nearest hundredth. So the idea here is that, it's not exactly perfect, but this parabola would cross the x-axis at about those locations. X equals and x equals. Okay. So the key here, the plus or minus sign definitely represents 2 possible solutions. One where that sign is positive and one where that sign is minus. Okay. Let's look at this expression. We have x squared. Again, we're going to subtract the 10 from both sides. So x squared plus 3x minus 10 equals 0. Right? So I suppose we could solve with quadratic formula and... Now, wait a minute. Must I? Because let's take a look at this problem. Okay, it begins with an x squared. So we know that a is 1. Now, when I look at a problem like this, I feel like this looks familiar. Might this be factorable? Can I say that maybe there are 2 numbers that add to negative or positive 3 and multiply to negative 10? Yes, it definitely looks like it. And so in this particular case, we have x plus 5 times x minus 2 equals 0. And if I were to do that, I have x equals negative 5 and x equals 2. Hey, well, that worked out kind of nicely because the problem was factorable. Now, is every expression factorable? No. One of the clues that I used with this one was the fact that there was a 1 in front of the x squared, no other constant term. So when that happens, I then looked at the other 2 numbers to decide, well, is that easily factorable? Now, some of the numbers, yes, we looked at a few units ago, some of the ones that had a number in front of there were also factorable. In fact, the first one kind of looks like one that we might have factored. It actually turned out it's not factorable, but that's okay. But some of those are. But those are a little bit tougher of a problem to do, right? So kind of naturally going to the quadratic formula was kind of a no-brainer there. But over here, because of the fact that the x squared was just x squared, it made sense to think about whether or not the numbers were factorable. And since it was, it saves us a huge amount of work. Now, could we do the quadratic formula on this? Absolutely. Yes, we could. we'll get the same exact answers of -5 and +2. And you can verify that yourself. But here's the thing. It says use the quadratic formula to solve each quadratic equation. How about maybe we cross that first part out and just say solve each quadratic equation. Now, sometimes, we have to know that we can use all the methods and we have all the tools in our toolbox. But if we have all the tools in the toolbox, why not use them, right? We can factor expressions, so let's use it when it's advantageous to. Quadratic formula we know always works, but does take quite a bit of work with some expressions. That's going to be the big idea for this particular unit, is understanding, when might be beneficial to choose one method over another, but also don't be afraid to choose whichever one works for you. Okay. So if we take a look at this expression here, so both equations were solved by two different people, right? Okay. So let's take a look. Attempts to solve the previous two equations. Let's see if we can spot any potential errors. Okay, first one, a equals 2, b equals -8, c equals 3. Looks like they've subtracted the 8x to get the b equals -8. Perfect. Okay, excellent. So going through this work, what do you think? Does it match what we did before? Definitely looks like it matches. Everything's good. Everything's good. Everything's good. Oh, what happened down at the bottom? Remember I said before that we were not able to divide by 4? Why aren't we able to divide by 4? It's because the number under the radical is under a radical. And so it operates under like different rules. So we can divide whole numbers by 4, but we could only divide that radical by another radical number, right? Now, if you wanted to write that as radical 16, because square root of 16 is 4, then you could divide the 40 by 16. But that's not going to happen here. 40 is not divisible by 16. So unfortunately, it's that very last step. That was just one step too far. The equation above it was actually correct. What about this one over here? So a equals 1, b equals 3, c equals 10. Solving using the quadratic formula. So they did it differently than we did. We did it with factoring. Here you can see how it's done with the quadratic formula. Oh, but they get no solutions. Oh, okay. And that's because they got a negative number under the radical. When you get a negative number under the radical, that means that the parabola is not crossing the x-axis. And since we can't take the real square root of a negative number, then that such equation has no solutions. But is that true here? What happened? Yes, the 10. They forgot to subtract the 10. So really, again, when we did last time, it should be x squared plus 3x minus 10 equals 0, and therefore c should be -10. So what does that change? It makes this negative here, makes the 9 plus 40, and so this makes this a 49. So now we can go back and we can actually now verify something. Hang on one second. All right, folks, sorry for the quick pause. I paused it to get around an announcement in our building, so that didn't show up on the video. Okay, great. So let's take a look here. So if we make the change here, it is a 49 under the radical. So what I now have is -3 plus or minus, well, what's the square root of 49? 7 over 2. Now, definitely, if you do a quadratic formula and you get a radical that is a whole number, right, and we end up getting the square root that's perfect, you definitely want to carry this out to the end. So what's -3 plus 7? -3 plus 7 is -4. So we're going to have two answers here. We're going to have -4 divided by 2, which is -2. And then -3 minus 7 is -10. And -10 divided by 2 is -5. Oh, I take that back. That's +2. -3 plus 7 is +4. +4 divided by 2 is +2. Okay, so we have two answers. We have 2 and we have -5. And guess what? We go back to the previous slide. Boom, same answers, right? Quadratic formula saves the day. So does factoring. Everything's good. Okay, so again, it doesn't matter what method you pick if multiple are available. You just have to make sure you're good at what you do. Okay, and as we stated before, right, so in this particular case, we understand that because we have the x squared, and the x squared is a equals 1, we can try factoring. Now, what about completing the square? Would we try completing the square with that? Well, my opinion is no. And the reason why is because the x term, the linear term, is odd. Completing the square works the best when the middle term is even. And the reason for that is we have to divide by 2 to complete the square. You take that middle term, you cut it in half, you square it. And if we have an odd number there, it produces fractions. I mean, sure, fractions are fine to deal with and all, but at that point, you might as well just be using, it's about no different than using the quadratic formula. So completing the square really only saves time over the quadratic formula when you have a equals 1 like this, and the middle term is even. If you don't have that, and definitely if you have a number in front of the x squared, unless you can take a look at it and quickly determine if it's factorable, then no, you're best off just using the quadratic form. Okay. All right, so here's a couple more options that happen here. And again, so this one, I'll just kind of leave my previous notes already up here. So a couple errors that can come up here with some of these equations when we work on them. First off, one very common mistake that happens when we solve quadratic equations is the students forgetting the multiply by a in the denominator. So in this particular case, we had a student who originally had a 2 that was in the denominator when it should have been an 18 when solving this equation. So 2 plus or minus root 40 over 18. It's a small change, but certainly one that is one to watch out for. It's the reason why people tend to forget that one is especially if you rely on the quadratic formula a lot, especially when a is equal to 1, we see those problems a lot. And so many times we often have just a simple 2 in the denominator, but it turns out that many times we do have an a that's not 1, so we do have to include that. The more that you factor expressions that have a equals 1, then the less often you make that mistake. Okay, equation 4, same idea, x squared minus 10x plus 23 equals 0. So here's definitely one that you could save some time by using completing the square instead of the quadratic formula, because you have an x squared and the middle term is even. Because at that point, then you'd have you're off by a perfect square by only a little tiny amount. Okay, so they go through the formula, and the first thing that happens, and I messed up with a plus sign here. Didn't need a plus sign here, but one of the things that this particular student did is they accidentally left all the negative signs in on the b. So opposite of b. So it should start with a positive 10, not a negative 10, and then squaring the negative 10 as negative 100. That's a surprisingly common mistake to happen. So hopefully that does not happen to you too often. So in this particular case, it does work. 4 and 23 are both positive. So you do, yep, 100 minus 92. And yes, you do get square root of 8 there. So the answer should be 10 plus or minus root 8 divided by 2. Okay, so that's just going over a few little errors there that can pop up and some common things that can go wrong when you use the quadratic formula. So that's about all that I have for you in this video. Just going over some kind of tips and tricks and when to use what method. And it's just at this point, just keep practicing your quadratic equations. Keep finding those x-intercepts. You're going to do awesome. All right, folks, have a lovely day, and I'll see you guys later.